All right, ladies and gentlemen, good morning, good afternoon. Hopefully, you all are doing well and staying and healthy, may I say. Alrighty, so today we're going to start lesson 17 and 5/10. Categorical data. The state of Texas expects you all to be able to summarize categorical data with numerical and graphical summaries, including the mode, relative frequency table, and the percent bar graph, and use these, amongst other things, to describe the data distribution. Alrighty, so which brings us to our first example here. Describing categorical data. Some data are quantitative, such as height or number of siblings of all students in a class. Other data are qualitative, such as eye color or favorite type of music. Categorical data are data that are sorted into categories on the basis of qualitative characteristics. You can use the mode, ladies and gentlemen, which is the one that comes out the most, to summarize or describe categorical data. The mode of a categorical data set is a category that occurs most often. If all categories have the same frequency, there is no mode. So what that means, in other words, ladies and gentlemen, the mode is the data value, or I guess the number, so to say, that comes out the most. All right. So in this next example, they're telling us that Carl sells red, blue, black, white, and green shirts online. One day, Carl received orders for 4 red, 5 blue, 6 black, 6 white, and 3 green shirts. Letter A, complete the dot plot of Carl's shirt orders for the day. All right, so here, ladies and gentlemen, they went ahead and did start us off here. So here, in this statement, they told us what he sold. Or the order that he received, may I say. We know it's 4 red, 5 blue, 6 black, 6 white, 3 green. Here, if you guys look at the graph, they've already helped us out with the red and the blue. So let's go ahead and cross this out. But before I move on, you see how he sold 5 blue? How many dots do we have here? 5, which each one of those dots represents one of the shirts that he sold, okay? Or that I guess that was ordered. Now 6 black, what do y'all think how do y'all think that would look? That would have 6. And that represents black shirts. Let's go and cross this out. 6 white shirts. So we got the white shirts taken care of, and 3 green shirts. And there we go. And that's how we would have completed the rest of the dot plot, ladies and gentlemen. However, here on letter B, they're asking us which shirt color or colors were the most and least popular for the day. Well, looking at this graph, ladies and gentlemen, the color of shirts that had the most dots on them are the black and white. So those were the most popular ones, so to say. However, which one was one that had the least, or was the least popular? In this case, it was green, because there's only 3 green. All right. So now, to identify the mode of the data, what do y'all think? Remember the mode? Once again, looking up at our description, is the categorical data set that occurs most often, the one that appears the most. Is there just one? Or what do y'all think? No, there's 2, right? Because black and white were both even. Both of them had, both of them were 6 times. Those are total 6 shirts. All right, and there goes that for that, okay? So now moving on. Summarizing categorical data with a relative frequency table. In the Explore activity, you plotted how many times a particular color shirt was ordered. The number of times a color was ordered is called its frequency. The relative frequency of a category is the ratio of its frequency to the sum of the frequencies for all categories. Relative frequency is often written as a fraction or a percent. For example, because 6 out of the 24 orders were black shirts, the relative frequency of black shirts is 6/24 or 25%. Example number 1. The table shows the results of a survey of students about their favorite summer sport. Make a relative frequency table of the data. All right, so here, ladies and gents, right here, they're telling us the sport and the frequency that was chosen by the students. So if y'all see here, this first part, or the top part of our survey here represents the sport, And the bottom one represents a frequency, or how many individuals chose that sport as their favorite. So basketball, it was chosen by 5. Baseball was chosen by 7. Swimming by 4. Soccer by 3. Track was chosen by 2. And softball by 4. So first of all, step 1, we have to find the sum of the frequencies for all categories, which means that how many total students were asked. In this case, if you add the 5 that chose basketball, the 7 that chose baseball, 4 that chose swimming, and so forth, there was a total of 25 students that were surveyed or asked. Now, step number 2, make a frequency table. Write the relative frequency of each category as a fraction of the total 25 and as a percent. All right, so here, ladies and gentlemen, the first one, let's work with basketball. We know that a total of 5 of the 25 chose basketball as their favorite. So how could we convert 5/25 into a percent? And I know math is beautiful, ladies and gentlemen. There's a lot of ways of coming up with an answer, so to say, just depending on your confidence or on your ability, I guess, of your proficiency in math, so to say. Some of you guys will see this that it's 5/25. And anyways, well, what I would suggest for the most part, ladies and gentlemen, is for y'all to do so by dividing. Y'all, top number goes inside your division house. Can 25 go into 5? No. So we add a 0 there. We bring up our decimal, add a placeholder 0. 25 goes into 50, and even 2 times, we have a remainder of 0, so 2/10. But that's decimal. They weren't asking us for the decimal, they were asking us for the percent. To convert a decimal to percent, you can shift your decimal point to place values to the right, and you add a placeholder 0. So it would be 20%. Another way y'all could have done it, ladies and gentlemen, is also as a proportion. We know that percent is always over 100. You guys could have cross multiplied here. 25x is equal to 500. Divide both sides by 25. And it would have also equaled 20. And it would have already given you the percent there. All right, so, but either way, it would have worked. So we know that 20% of the students chose basketball as their favorite sport. 28% chose baseball, and so forth. All right, so I'd like for you guys to go ahead and try number 2 on your own, please. Alrighty, so number 2, your turn. The telling us that Chewy has 40 dimes, 20 pennies, 10 nickels, and 10 quarters in his coin jar. Make a relative frequency table of the coins in the jar. All right, so here, ladies and gentlemen, what are we comparing? What are we comparing? We are comparing dimes, pennies, nickels, and quarters. So now, in each, ladies and gents, before we move on, because they're asking us for the relative frequency, we need to find out how many total coins he has. If you guys add 40 plus 20 plus 10 plus 10, that equals 80. So that's going to be, of the total of 80 coins, how many of those were dimes? 40. And if you guys convert, well, if 40 80ths, that is equivalent to 50%, which y'all can look at the previous example as to how we did that, by dividing or using a proportion. For the pennies, I'm going to color code it here. Out of the 80 coins, how many of those were pennies? 20. So 20 80ths, that's a 0. This is equivalent to 25%. Now, nickels, of the 80 total coins, 10 of those were nickels, which means that 12 and 5/10% are nickels, and quarters would be the same because it's the same amount. So that simplifies to 12 and 5/10%. Okay, so that's what y'all should have had, ladies and gentlemen. All right, so moving on to the next one. They're telling us that using a percent bar graph to describe a data distribution. You can describe relative frequencies in a percent bar graph to help you visualize how the data are distributed. Example number 2. They're telling us the table shows the results of a survey taken in Mr. Jenk's music class about the students' favorite musical instruments. Make a percent bar graph. Then find the mode and describe how the data are distributed or how the data is distributed. Let's find out. All right, kiddos. So here, if you guys look at the graph here, they're actually showing us distribution of the data, which means the way we would interpret this is that when it came to drums, a total of 6 kiddos surveyed chose the drums. But in order for us to come up with the percent bar graph, ladies and gents, we need to find out how many total students were in Mr. Jenk's music class. If you add all of these here, 6 plus 5 plus 3 plus 3 plus 2 plus 1 equals 20. So of the 20 students that were surveyed in Mr. Jenk's class, 6 of them chose drums, which means that 30% of the kiddos chose drums. 5 of the 20 chose guitar, which is 25%, and so forth, ladies and gentlemen, which is what step 1 was basically telling us to do. All right, so step number 2, because they also asked us here at the end of the question, was then find the mode and describe how the data are distributed. So in this case, the instrument that was chosen the most, or that came out the most, was drums. So that would be considered your mode. So the instrument mentioned most is the drums. So the mode is drums. Although the guitar is nearly as popular. It wasn't exactly as popular, but it was nearly, because it was off by 5, which is the closest one. More than half of the students, 55%, favored drums or the guitar. About a third of the students, 30%, favor the brass or saxophone. All other students, 15%, favor the trumpet or clarinet. Okay? And it just depends. I mean, on these, they're not gonna have you guys come up with your own phrases. They're gonna give you guys like a graph like this, and they're gonna give you guys several sentences. They're gonna ask you, okay, you know what? Based on the given data, which of the following statements is true, and so forth. All right, I'd like for you guys to go ahead and work on number 4. All right, ladies and gentlemen. So for number 4, they're telling us that Devin is growing tulips in his garden. He has 24 tulips, 11 yellow he has 24 red tulips, 11 yellow tulips, and 15 purple tulips. Make a percent bar graph and describe the distribution. Ladies and gents, look at your y-axis and your x-axis here, because that's crucial here. So first of all, how many total tulips does he have in his garden? He has a total of 50. Of those 50, how many of those are red? 24. So converting that into a percent, ladies and gentlemen, that is equivalent to 48%. Now, let me color code this here. That's the red. Now for the yellow, we know that 11 of the 50 are yellow, which is equivalent to 22%. And last but not least, we have the purple, which the purple, ladies and gentlemen, was a total of 15 of a total of 50. And once you convert that into a percent, y'all will establish that 30%. So they're asking us to make a percent bar graph. So here we're discussing, or we're working with the red. The red, ladies and gentlemen, was 40%, which would extend kind of all the way up to, right there. So that is the distribution of the red. Now, next, let's work with the yellow. The yellow, ladies and gentlemen, was a total of 22%, which would have been somewhere around right here, 22%. And last but not least, we got the purple, which was 30%. So that would have been right here, ladies and gentlemen, okay? So that's what y'all should have had right there. So, hopefully that helped you guys out. I'd like for y'all to please go ahead and work on the guided practice. I'd like for y'all to please work on 1 and 2, 3 and 4, and also on the independent practice. All right, because on the independent practice, please only do number 6, 8, 9, and 9A, please, okay? All right, kiddos. Sorry, my time is up.